You may have noticed that I put an asterisk up here on the title. I'm going to go into that real quick because the title of this presentation, I actually lied about it. I've had some previous talking tos with our risk management group about getting into a little bit too much detail in how we do our architectures in other talks. So since I'm a very lazy person, I submitted it to them 2 weeks ago, and by that time it was too late to change the title, so I left the title. So instead, we're going to talk about this, but it's going to be at about 100,000 foot view. I thought that it would be more interesting to get into how we did Puppet wrong when we started, the mistakes made, and then what we did to remedy the mistakes, and then how we're scaling out globally. I'll take questions on it, but I don't want to have to talk to our CPO again, so let's try to keep the architecture questions to something that's not super detailed. Is that okay with everybody? Does that sound good? Are you pissed? Does anybody want to punch me in the face? All right, cool. We will continue then. I forgot to mention, so the way I broke this down is I'm going to give a company overview of what our company does. I'll then go into why we adopted Puppet in the first place. I will then go into the main 4 mistakes that were made when we implemented Puppet when we first started the DevOps movement inside of MHE. And then I'll go into how we refactored Puppet to make it work for our scaling needs. And then at the end, I will talk a little bit about how we're scaling it globally today inside of Amazon Web Services. McGraw-Hill Education, we're a multi-billion-dollar print and digital company. We were recently divested from McGraw-Hill companies last April. That means that we broke apart. We are now a single operating entity all by ourselves. We're fully owned by Apollo Global Management. Something very important to note here is that McGraw-Hill Education has been around for like 110 years. Traditionally, we've done print. We have an accelerated movement internally inside of our company, and you're seeing this a lot with a lot of print companies, of shifting to digital. So our time frames on things to get things out of the door and then get it like overseas and like China, stuff like that, I mean, they are super aggressive. So I'll talk about this on the next slide of why did we even turn to Puppet for automation. These are some of the main reasons. I mean, when I say months of lead time when I started at the company, I mean, it was like 3 months to get a server, like a VM in the data center. Obviously, if you're trying to create new digital product and then deploy it so your customers can buy it, 90 days isn't going to cut it. A lot of times, we'll literally have weeks to do things, depending on the size of the actual product line. So Puppet helps out a lot with that. Just again, because the timelines are super aggressive. We had a CMDB. It was pretty much out of date and always wrong. So if you guys have done traditional CMDB implementations, you guys are probably very, very familiar with that occurrence. So like I mentioned, we use AWS for product delivery. Basically, what Puppet allowed us to do in coordination with AWS is instead of taking that 90-day model, we literally can get servers out the door, deployed, doing work for customers in a matter of minutes now. It's not just Puppet, but Puppet plays a huge role in that. One real-world example I like to give is when we first started kind of our cloud movement and the automation of both how we do release management and how we do infrastructure automation. We had about a 3-month window to deploy an entire SDLC for our biggest application that we have internally called Connect. Millions of users, tons of revenue generation for the company, literally thousands of servers. And with the help of Puppet and Amazon in that particular case, we deployed right around 3,000 servers, fully operational in 2 months with 2 people. So if that's going to give anybody an idea of the power of what Puppet can do for you, there you have it. Again, the scale up quickly and the cloud quickly. I just kind of gave that in that example that I had there. And then the last one was continuous integration and continuous delivery pipelines for our software. This really didn't exist until we kind of started the DevOps movement inside of MHE. Now, kind of my mission statement internally to our company is how can we enable development to get code out the door as fast as humanly possible and still ensure reliability and uptime to the websites. So Puppet, again, plays a huge role in allowing us to do that in a very controlled fashion. So I spoke a little bit about our rapid timelines, and it's super aggressive. And I've worked for big corporations. I've worked for startups. Startups are usually pretty hectic. This one also is pretty hectic. So just kind of going into this, these are the main 5. The fourth one I kind of broke into 2. Just to go over these real quick. We wrote all of our modules wrong. I don't know if you've ever started with Puppet. I mean, a lot of people will do modules based on Node or something like that. Like, I have an Apache server. Okay, super. Well, we've got 10,000 products in our environment. You need Apache on, let's say, 2,000 of them. I mean, how are you going to do the configuration control across the different environments, across the different products? So we weren't doing any code abstraction, which is not good when you're talking about multiple products, multiple environments, in multiple regions around the world. And I'll get into how we fix that. The second one was not integrating into a code repo. I can't stress this enough. This was the stupidest thing I've probably ever done in my career. I don't care if you're starting in a startup and you have $0. GitHub's free. Integrate your code. It's very easy when you're working in like a team of like 2 people to, okay, you're making this change, super, let's go. When you start scaling globally and you have global teams working on things and making infrastructure changes at any given time, you need to know who's doing what and what changes are going out the door. Luckily, this one didn't really bite us in the butt, but we did start off this way. I highly recommend not doing it. The Puppet code not being integrated, I talked a little bit about the continuous delivery pipeline for software. We didn't have Puppet code integrated into how we do release management. Puppet is code, so our infrastructure is code. When we're releasing our software code from our development teams and our software from our DevOps teams, it should all be treated the same way, under the same mechanism, the same release mechanism, under the same change control guidelines. And then going back to that, I mean, just poor QA processes of like not doing code reviews, not going through QA automation whenever we were making infrastructure changes, things of that nature. And then the last one is the Lifecycle Management tool. Internally, we use Foreman as our ENC. And I'll talk a little bit more about that later on. Okay, so how to make our implementation better. IT is a very crazy world, as everybody in this room knows. To me, it was taking the time to actually sit down and look at our Puppet implementation and then just figure out what was wrong with it. So I hired more DevOps engineers, more Puppet experts. We took a step back. We looked at the overall scheme of what we were trying, or the company's trying to do, like business objectives on a global scale. And then we looked at how we were doing our automation, and then so we realized that we were doing things wrong, and it wasn't going to allow us to scale efficiently and fast enough. So I basically paused some of the projects, said, okay, we're going to make time, we're going to change this stuff. And then we finally got a break to actually go in with the help of Puppet Professional Services. And not to toot their horn on that, because I'm never I don't really promote vendors that often. I will tell you that Puppet PS is awesome. The guys that I've worked with there, very knowledgeable, very skilled in what they do, as well as help with my own internal DevOps people that are a lot smarter than I am. So here's what we did about the 4 things that we really screwed up when we started this. All right, the module refactoring. I talked about that we were doing basically assigning modules to like a node or a many nodes doing the same function, but we didn't really have any classification around that. So the proper way to do this, and mind you, you can write your Puppet modules however you want. This is just the way that works for us, is to take those components, like the examples I give here. We use Apache extensively internally. We use WebLogic. We do use Tomcat. We're primarily Java. And then just other infrastructure components like your monitoring software, like your patching software, or your patching agents, I should say. You roll those up into a profile. Like, okay, great, you're a database or you're an email proxy, so you need X components coming up. You then roll those out with a role. So the role basically is just the business logic. So for instance, to give an example on that, for like our MH campus product, you have a development web server for MH Campus. So the role is you're a web server for MH Campus, so you get assigned X profile with X components, let's say like Apache and HA proxy or something like that. What this allows us to do is the code abstraction here, which I kind of talk about down at the bottom. So we're getting rid of that. And what this allows us to do is that you can now have similar components that you can reuse all over the org. So we have a ton of products inside of McGraw-Hill. So we're reusing code constantly. So this was the biggest portion of being able to scale faster for us, was being able to take the code that engineers have already written and then super fast and efficiently roll this up into a new profile that was suited for that application. The code repository integration, again, I put that we don't really need to talk about this. I mean, this was just stupid. Don't do this. I mean, some of the benefits here are change management, code check-ins, who's doing what. I mean, again, if you have global teams working on code, you need to know who's changing what when, integrated into your change tools. Another problem that this presented us with before we actually came in and actually cleaned this up was we had a lot of puppet masters in a lot of different environments running for different products, and we kept all the packages on there. All the code was on there. So I mean, we basically had these huge puppet masters that were very fat, going back, taking a look and saying, okay, well, we need to back this stuff up because if we need to do DR or bring something up in another country, et cetera, we need to be able to pull this off of a backup in case of a disaster. So just thinking about the cost of that, I mean, it was very expensive. So the way we do it now is we integrated with Atlassian Stash because internally we use pretty much the entire Atlassian suite. And then we keep all of our necessary installers, et cetera, in S3 if they're needed to be called by Puppet. Puppet code being integrated into our CD pipeline. I talked about that we didn't really have good release practices around how we did our infrastructure code. Today, QA is very important. If you don't have quality code coming out of your modules, then you're not going to have good uptime for your website. So, I mean, if you're not catching this stuff in earlier environments, as you guys know, I mean, you can screw up one thing, one configuration, you push it to prod, and then production goes down, and then everybody's mad. So the way we do it internally, and mind you, this is just a sample SDLC. We have a lot of different ones for a lot of different applications. We'll push the code to development and do peer reviews. Then we will take Jenkins for our CI tool. It'll then push it up to higher environments where it will be touched by all of our Selenium QA automation. And then we will then promote it into a performance environment where, if need be, it'll be load tested, depends on the changes. And then, although we do things in a very agile style, I don't want to sit here and promote that like we're doing full-blown CI and CD, because we certainly are not. We develop code in agile, but basically we allow that code to build up, and then it'll basically sit at the doorway for production, and then we'll release whenever the business tells us that they're ready to present it to the customer. But I don't want to take that away from the Puppet work that we've done, because a lot of times if we needed to get something out of the door, like in an hour, I mean, we can develop it, push it up, and be production ready and running, again, in a matter of minutes. The ENC implementation, I don't know how many of you guys here use an ENC. I don't really want to rip on Puppet's console, because they showed some pretty cool stuff on the keynote this morning. But we picked Foreman for a bevy of reasons. Mostly, it has a wide community usage, and we also have internal knowledge of it from other companies, so it made it easier to implement. Basically, it's kind of like the node manager you saw this morning. It allows you to manage a lot of the repeatable tasks, like things like grouping or like server deployment, stuff like that. It also improved our audit capabilities, because we do get audited for PCI and PII data, et cetera, et cetera. because it aggregates all the logs, and then I literally can just hand the logs over to the auditors and say, here you go, here's everything that changed in the last 3 months. Enjoy yourself. It also allows us to do orchestration. Puppet is great at doing the infrastructure automation, but it is not good at doing infrastructure or orchestration of an environment. And what I mean by orchestration of an environment is not only bringing up like an EC2 instance, but also pulling code out of, telling Jenkins to pull code out of a repo, populate the code on the server, talk to the Amazon APIs, implement it into the ELB, and then have it up and running and actually doing something for a customer. Puppet's not going to allow you to do that. You're going to have to get into other tool sets to do that. They did talk a little bit this morning too about doing some more things around orchestration, so it'll be very refreshing to see what they do there, because that's a big need. Another thing that we do orchestration for would be developer needs. So Amazon has like tons of tool sets in their toolbox, and developers like to play with stuff to see if they can make their application run better. So allowing the developer to go into a web interface and say, I want to play with Elastic Cache today with a small scale setup of my application. Hit the button, go, build it, populate it with the code, and then test it. And then if you want to use it, maybe we'll build it up in the higher environments, and then we'll do some more performance testing on it, and maybe it eventually gets into production. And then ENC, it's better for our ops team to monitor configuration drift. Again, going back to Puppet's current implementation of the console, I can't expect our actual level 1 op engineers to go in and learn how Puppet works. So the form in itself allows for prettier graphs and things of that nature.
What sort of tools are you using for orchestration?
Sorry?
What sort of tools are you using for orchestration?
So it's internal. It's either we script it. One that we did look at pretty hardcore last year was using RightScale for it. RightScale is more of a wrapper for things you do in Amazon, though, and it was going to be a lot of work. So it's actually easier to script it. Like we do a lot of scripting in Python to call the Amazon APIs to do population, or to, like I said, put a server in an ELB, grab code, etc. All right, so here's what the original talk was going to be about, and I had some pretty graphs and how we did it, and that wasn't going to fly. So here's how we do it inside of Amazon. Basically, we use a Puppet Master per environment, and then we deploy Puppet Masters for multiple systems or multiple products, depending on the workload that we think the Puppet Master is going to get, if that makes sense. We don't want to overload it, although we can scale it out, which I'll talk about in the second bullet point. We deploy it in each environment from dev to prod for a couple of reasons. One, it allows us to QA our modules from environment to environment. It also allows us to do upgrades more efficiently. So if you needed to upgrade to like 3.7 and you're running like 3.4 and you're scared what it's going to break, you obviously don't want to rush in there and say you got one Puppet Master controlling the entire thing. You don't want to upgrade that because you could effectively make your environment to where it's unusable, because Puppet breaks and all your modules break. So what we'll do is we'll start with the upgrades and development. If everything goes good, then we'll push it into QA, we'll push it into perf, and eventually into prod. Other regions outside of the United States, since the bulk of our teams do the work inside the US, they're pretty much just production systems. We do one Puppet Master per region, per application. And this just, again, on the scaling portion, it just depends on the workload of the server. If we need to scale out because we have Puppet managing Puppet, then we'll just deploy more masters, stick them behind an ELB, and then split the workloads up. And then also, all of our Puppet Masters feed from the exact same repo in the United States right now. So all the code's centralized. And then we still use Jenkins even to deploy code everywhere else. So I should have put a disclaimer on this because I had to change this about 2 weeks ago. This presentation was going to be extremely short, so we were going to have a lot of time for Q&A. So
run over and give you a mic. Just a simple one. What are some examples of your applications? I mean, I assume your website's selling the books, or what are some of the other apps that you guys run?
Well, so I mean, we do a whole bevy of things. Some of our platforms are full suites for, like, we write software for K through 12, higher ed, international customers. We do like ebook sites. We do e-readers. On some of the suites, I mean, it's everything. It's from managing your rosters to grading to quizzes, handwritten assignments, to whether or not you're going to graduate high school. It's just, it depends on the product, but we're pretty much in all of it. Which makes it even more important to make sure that you have all your stuff situated properly, because we don't want to have the overlapping.
Could you talk briefly about keeping your Puppet Masters in different regions in sync? Like, how do you know that the code you're deploying, say in like the Singapore region, is the same version that you're getting in Texas?
Because of the version of the code that's actually sitting in the repo, and then we tell Jenkins to grab the code versions. So depending on the repository we're using, because we have lots of different repositories internally, basically we do it by tag name, and then so it'll say this tag, like version 1.06938, go out and deploy this here. So we basically, so DevOps does the release management as well. So it's literally dev or QA will give us the code. If it's internal to DevOps, like infrastructure, then we'll say we're going to release this tag with release 7B going out at the end of September. So we deploy these tags up, we'll test it, and then it'll eventually just float into production. So it's the same principle. It doesn't really matter where it's at. Actually, the biggest issue, and something to point on, was the latency issues too there, of doing it via the internet, which I don't recommend doing if you're on Amazon. We actually deployed MPLS into all of our VPCs regions, just because we needed to have the SLA on the line being up, and then the actual latency guarantees.
So we use a few like exported resources. How does that work on a global scale? Or, you know, because we have trouble keeping that database kind of cohesive. Sometimes if nodes disappear and then we need to manually remove them, how do you guys deal with it, or do you even use it?
I'm trying to think of a specific example I could give there. I mean, we've had some issues keeping the masters up to date with the inventory properly, if that's more or less what you were getting it at. Some of that stuff is either a bug in Puppet, and some of the stuff we fix running cron jobs on Linux, which is a really, I mean, frankly, it's a really shitty way to do it. But there's not really a way that we could think of internally to fix that, to clean some of that stuff up. Did that answer your question, kind of, sort of? Yeah. Yeah, no, so I mean, it's, I guess I answered it, but I guess I didn't put it in the, we do have the same problem, but we've had to write scripts to go in and actually do the cleanup jobs. On some of our products, so some of the stuff we auto-scale, we see a big problem with this because nodes will pop up and then they'll go away constantly. And then we have ran into issues with Puppet having issues keeping up with that. So we do run checks, but it's manual code that we've written. It's not really anything magic that we've done inside of Puppet to make it work.
So you briefly mentioned Lifecycle Management and CMDB. Can you elaborate on that a little further as far as your implementation and some suggestions that you could give for us?
Well, so Lifecycle Management, well, let's sit on the CMDB portion first. That's important because we need to know that the configurations are the same from environment to environment. They gave a really good example this morning in that keynote of like that ERP implementation, and then it breaks because there's one thing that's changed in production that was different than in your performance environment, for instance. The CMDB, and this is one of the great things that I love about Puppet, is because it's tracking the configuration drift of the servers too. So we know that every single server running in production mirrors exactly what was in our performance environment where we did the load testing. The same thing with the lifecycle management of taking the code that we write in the modules, or even the code we write in the software from the development teams, and then tracking that from literally its inception until it gets released into production. And this is more important to me from an audit perspective because we have to adhere to like PCI requirements and things of that nature. So I need to be able to track down who did what and when, so I can give the auditing, not just give the auditors proof that nobody was in there trying to steal credit card numbers or something like that. Now more than ever because of all the security breaches that have been happening. And then obviously the other portions of making or tracking your code to make sure that if it goes into QA and it fails, or let's say there was a massive performance degradation of pushing the code back, doing a rewrite, getting the version or the revs re-updated, and then tracking that back through. And then so we use Atlassian, Jira from Atlassian to do our bug tracking internally. So if it fails, then it would just get kicked back, and then the bug would stay open. Or we would do a new bug ticket if we didn't know about it, and then we would fix it, and then we'd push it up just like development does.
I think I have the next one. So I noticed something about a Puppet master per application. So can you just talk a little bit about design considerations and why you went that route and kind of what forced you in that direction, and maybe other things that you may have tried that weren't as successful and how you landed on that particular design configuration?
That's actually a very good question. Let me think about that for a second. You know, I honestly think that we started doing that because we started with a single app that we were puppetizing, and then we just never really went back and changed it. Because it was funny because, I mean, you're coming into an org that it's taken like 90 days to get a VM, and then we're over here showing that we're scaling out thousands of servers in a matter of months, and then so everybody else is like, I want that, I want that. And then so our work intake went crazy, and you know, I mean, I'll have to mull that over, but I really just think that we just didn't go back to change it. And we haven't really hit any snags with it, to be completely honest with you. I mean, it's been working.
Can you elaborate a little bit more about the last mile you do from Jenkins to your masters? I mean, how do you get there from the Jenkins? You said you have a central Jenkins and you're publishing to all the
So it's just
public
we
masters?
use SSH to push the code, so that we just have regular named accounts for Jenkins to go in. It'll log into the server and then update it.
Hi. Two questions, both about testing. How much automated testing do you do, and what are the human controls after something passes in your QA branch before you go to production?
It depends on the application. Obviously, the applications that make more money for us get a lot more budget to do things like JUnit testing or Selenium scripting. Typically, like on a bigger application, the developers will write the JUnit, so when they check the code in, it'll make sure that the code's sound. Then when they push the code to QA, because DevOps kind of stays out of the way between that development and QA aspect, because if they're ready to push code, let them push code. They don't need to talk to me. And then QA will kick off their automated processes inside the Jenkins job. And then if it fails, then we'll look to see where it fails, and then we'll notify dev, and either again, like create a new bug fix, like say, hell, I don't know, the user login and the assignments weren't coming up on the right side of the screen. Can you take a look at this? Something's going on. And that could be either just because the code's broke, or maybe the response time is terrible and it's timing out or something like that. But that's typically how we'll do it. We try to automate the whole thing as much as humanly possible. Again, going back to that, the continuous integration, the continuous delivery. Although we do a lot of automation internally, I shouldn't say never. I think it's going to be hard to convince my company until we get better process across the board to allow a developer to check in code, it to go to QA, kick off all of its jobs, validate that the code's good, it didn't break anything, and then push it to production automatically. I mean, there's tons of companies doing this that are a lot larger than ours. I don't want to say that we're in the infant stages of how we do automation at McGraw-Hill, because I think that we've passed that, but we still have a lot of growing up to do.
Yeah, I have a question about your testing environment. Is your testing environment primarily a static environment, or, you know, like after you install one of your packages and you test it and it doesn't work, do you destroy that environment, or is it spun up like with Vagrant or something like that?
So
You test it and go.
it depends on the product. We do have some products that are 100% the whole environment's automated, where we'll do teardowns and rebuilds. We also have some legacy product that we've had to migrate that we didn't have the luxury of doing like full bore automation on the entire thing. So we will keep things out there static to a certain point. And then if you guys are familiar with Autoscaling in Amazon, as more traffic comes in, then we can scale it out accordingly. On some of our bigger products that we didn't get any funding to do any rewrites to make it more Amazon friendly, we will keep it static, and we'll just have to roll it back if there's a problem. A lot of times if we have issues though, like in production, or if we have a node doing something stupid, like in performance or whatever, we'll typically just go in there and destroy the node and then just redeploy a new one. There's no need to troubleshoot it.
Is there any advice you would provide to someone new to Puppet, say top 3, right? Based on your, you had a good summary in here, right? But just starting out, what are the top 3 things when you're getting started with Puppet based on your experience scaling globally?
Number 1, I would say really think about how you want to do your modules, like logistically lay the stuff out for whatever your business need's going to be. I think a lot of people don't think about that, and I know we damn sure didn't. It was like, okay, well, we're just going to puppetize Apache, we're going to puppetize WebLogic. I don't really care what the business need is. And now we come further down the road, and we have like the massive workload and then all this stuff, and we don't want to have to rewrite everything. So it's just a lot easier if you go into the roles and the profiles. You can just reuse the components for whatever the application is. You put it into the profile, and then you roll it out, pun intended. That would be number 1, just because that was the biggest deal. And that was the biggest issue to fix, too. Because, when you're going at such a high velocity, you're creating tons of modules. And then you have to go back and refactor all that code. And, that just takes time and money. So, other ones. If I was talking to somebody that wanted to start Puppet today, that would be probably my number 1. Don't do that. Again, and then with the code repo, and that's just more of just don't be an idiot.
Any other questions? All right, Shane, thank you. I think you're free. Oh, do we have one more?
Yeah, we use the standard one. Yeah.
Do you mean, like a, yeah, so in
Oh, no.
PE, they whip out
We do
WebRick,
not.
so no one's using WebRick, hopefully at that size.
We use stock.
Any other last minute questions?
What are you doing for controlled rollouts, like when you do module changes? Potentially, like if you write an Apache module that could touch 1,000 web servers, and if you make a modification to your Apache config and you have it do like a refresh on the service so it reloads that web page, essentially, if you check that into your masters, all of your web servers within 30 minutes from the default config of your Puppet master will refresh. So do you have any mechanisms in place to kind of control those rollouts to a segment of servers?
Yeah, so that's where the roles come into play. So we divide it up by application. So it knows that it's a production web server for our Connect platform. So when you go in to that actual module and you're modifying that portion of it, then that role is just going to go up and touch that one server. So whenever you're modifying it, you're not going to have any overlap. You know, it really depends on the application architecture, to be completely honest with you. So we have a lot of stuff running in the cloud right now. Again, I don't want to be too ambiguous here, but some of the stuff we got to architect from the ground up and make it pretty sweet, and then other stuff we didn't get a chance to architect at all. And we didn't forklift anything by any means, but we didn't do it the way we wanted to do it. So we do the maintenance on things different per application, which does make it difficult, but I mean, it is what it is. Sorry, I know that didn't really answer your question, but it's just, we have a lot, we do it different on every app.
So quick question, because I come in a few minutes late. How many apps, how many engineers you're talking about for your team?
Application-wise, I mean, I don't want to get into the specific numbers, but I mean, it's hundreds. We literally come from like pre-K all the way up to like PhDs. So I mean, there's just a lot of stuff there. Engineering-wise, on my specific team, we have 21 engineers that work on separate teams globally. Typically, the way that I do it is I have DevOps embedded in where the big development teams are. That way, we're just tightly integrated with dev. So as they're making changes or need things, we're involved from like iteration 0 of the sprint to know, okay, you're going to need this. We're going to start doing the work for you. So that's typically how we manage it. How many systems? The servers and like server counts? It's thousands. I mean, I'd have to log into our AWS accounts to give you a count, but I mean, we're well over 5,000 by now.
All right. Thank you very much.
Sorry for changing the context of the presentation.